Let's investigate this idea, theory of constraints. How about this quote by Martin Villeneuve? Problems are hidden opportunities, and constraints can actually boost creativity. What if your customers wanted more of your product than you can produce, and they want it now? This is a great opportunity for your organization, but what would you do? Would you add another shift, install another line, or expand to another building? Or would you determine how to get more product through the bottleneck of your existing process? If you could figure out how to get more product volume through your existing process, you'd generate additional revenue more quickly, resulting in increased profit for your business. The example depicted here shows a constraint on the left, and we improved that constraint on the right, and we're getting more product through the bottleneck. So this idea, theory of constraints, was first introduced by Eli Goldratt in 1984 in the book The Goal. It's based on the idea that the throughput of the value stream or system is limited only by its constraints or bottlenecks. The methodology is used to identify and improve or eliminate the constraint, which restricts or prevents a process from achieving a throughput goal. If you look at the image here, we have customer demand, and that's indicated by the black lines, the straight black lines. We have capacity, indicated by the width of each process step, and the workflow. And you'll notice process step 5 is constrained below the customer demand. This is where we would focus our efforts. If we could improve process 5 to equal the customer demand, every other process would be capable. That's what we're trying to do in the theory of constraints. So let's look at this theory of constraints cycle. First, we're going to evaluate the current state process and identify constraints that limit achievement of the throughput goal. We'll then exploit those constraints, making small and rapid improvements to the process at the constraint location. We'll subordinate all other steps and activities in the process so that we can focus on the constraint, ensuring they support improvements to the constraint. We'll elevate the constraint in the process to successfully achieve throughput goal by applying more advanced and sustainable improvements. This step's considered breaking the constraint and may result in identifying a constraint somewhere else in the process. And we'll repeat the continuous improvement cycle for additional or new constraints that limit or prevent the process from achieving the throughput goal. So constraints may be internal to our processes, systems, or organization, and those could be policies, people, and equipment. They may also be external to our organization, such as regulations that are changing or scarcity of resources. Regardless of whether they're internal or external constraint types, applying theory of constraints, it's an excellent approach to identify and improve or eliminate the constraint. It's a continuous improvement cycle. It can be used as a standalone methodology to improve throughput, or it could be a supporting methodology to A3 thinking, or Lean Six Sigma, or design for Lean Six Sigma. There's some tools that support this theory of constraints idea. A Pareto analysis to focus on the 80-20, the most important issue, the most important constraint. There are flowcharts or process maps. Our scorecards, our key process indicators, should identify the constraints. We can use a responsibility matrix, a cause and effect diagram to look for all of the potential causes for the constraint, a root cause 5 why analysis to get to the root cause of the constraint, and even brainstorming or affinity diagram as well might support theory of constraints. So don't forget to download your complimentary Excel toolboxes. They can be found at valuegenerationpartners.com. Select the download page, and any of these toolboxes supporting these various initiatives are available, and they contain many, many tools and templates. So wishing you best of luck applying theory of constraints to your bottlenecks in your processes to improve your process flow and your volume of throughput.